silos, right? Because those are very expensive. Then you're constantly moving data between different systems to do different things, right? So the more we can enable companies to provide a shared service where the data lives in one place and you can bring different execution engines to that data and let people run, batch processing or interactive SQL or other types of workloads on that data, the better, right? And then I think if you think about like Apache Drill, for example, being the first major kind of distributed schema-free SQL engine, the idea is not that you will never need schemas, right? I think there comes a time when you've decided that the data is very important and you want to apply schemas and govern that data in a very tight way. But if you think about data now, the way at which data is growing, both in terms of volume and variety, it's growing exponentially. Every various numbers out there about according to one piece of research, it's doubling in size every 2 years. Well, the DBA teams aren't doubling in size every 2 years, right? The IT budgets aren't doubling in size every 2 years. They're growing like 2% a year. And so it's pretty clear that most of the data companies just won't be able to manage most of the data the way they perhaps could have in the past. And they're going to have to live with the fact that a lot of the data is going to be unmanaged, ungoverned, more kind of free form, and enabling the users to explore that data, to analyze it. And yes, for that 10% of data that is found to be very valuable and needs to be very clean for closing the books or doing other analysis of my sales pipeline, then yes, that's fine. You could then apply schema to that. But there will always be that 90% that people still want to explore.
Okay. Any other thoughts on that topic?
Sure. My sense is that you need a happy medium. People are willing to silo, but not too much. I mean, they recognize that occasionally you need a different tool for a significantly different task, but you don't really want to have to decide among 20 different tools. Right? I mean, I have 2 cars, not 15 cars. Right? I mean, if I'm going to Tahoe, I take this car. If I'm going to San Francisco, I take that car. If I'm driving around the corner, I might take my bicycle. But I don't need 15 different cars that are just incrementally different, overlapping most of their functions. But I mean, if I need to do a gigantic kind of batch data pivot to optimize my sales force, and I've got gobs and gobs of data, the appropriate tool would be some flavor of MapReduce running on Hadoop, Cloudera, something like that flavor. If I want to do initial data exploration, I want to do general purpose computing with these data, then I want a database. And I know what a database is. I have a client, I have a server, I send them a query, give me back an answer, and I iterate through it. I want something that has that flavor that I can get running fast, tells me what's in there, and I can start exploring. Right? So that's 2 silos. And a search engine. Right? That's a different piece entirely when you do searches. So 3 is a reasonable number. Big analytics, search, and a general purpose database.
Okay, thanks. So Robert, I have a question for you, being that you represent Big Red here. So we're seeing. What's that? It is. So we're seeing a lot of companies already start to introduce JSON data types into their core platforms. Right? Oracle's done it. Teradata's done it. IBM has done it with a partnership through MongoDB. Is the window closing for some of the data type specialists in the NoSQL space? Are we about to see the Bambi meets Godzilla moment in this space?
No, I'm not even quite sure why you're asking that particular question. Just
well, because we saw it with XML. Now we're seeing it with JSON. So is it really more about architecture, not data types?
No, I think that the utility of JSON is definitely superior to XML. I think that Paul was right. That, as web-based architectures have come into existence, there was this thought that we would introduce semantics and all of this stuff into the web, so we could have machine-based learning and crawlers that go around and basically become our thinkers for us. And it hasn't quite got to that yet, but it's trying to move in that direction. XML was a spec that just was a little overboard, and the average person couldn't really deal with it. It became too much of an obstacle in delivery. And JSON, I think, has fixed a lot of that. And so I think it's better from that perspective. So it's a new valid, relevant data type. And so all of the data management companies are bringing it on as a new data type, as they quite frankly should. And so when you're dealing with, you're not going to see that coming off of the robots, right? You're not going to see it coming off of real-time manufacturing floors. You're going to see, so it's going to be used where it's appropriate, but it is appropriate. It's not going anywhere. So these technologies need to embrace it. They need to figure out how is it that they can ingest it, and then they can process it just like they did any other data, which they're all doing now very, very well. Quite frankly, with SQL these days. So I don't think it's Godzilla versus Bambi here. I think it's just, it's a very, very good data type, and it's just going to be embraced by the systems. The things that are, the Godzilla versus Bambi, I mean, maybe it started out as Bambi, but I think NoSQL taught the database world where there was a time when nobody had to, to argue the point about superiority. I mean, it was, it was the big three. It was IBM, Microsoft, and Oracle, right? And so,
Well, and SAP.
well, yes, but there's always a second tier.
It's a $32 billion market.
Right.
You guys don't have all of it yet.
So I was generalizing, but thank you for pointing that out. But what NoSQL did, which I think was very, very important, is it basically brought into light that people do value agility. They do value the ability to have new ways of development, continuous integration, and these tools made that easier. And what they really did is they highlighted the fact that the relational technologies kind of got stagnant for a while because they didn't have to do anything. And so then so in some respects Bambi kind of like made peed on the foot of Godzilla. And Godzilla woke up a little bit, right? And realized that, oh, I need to do something. And so now they're doing something, right? These vendors are making changes. They're making their systems more installable so that you can get one up and running. Of course, with the cloud, it's kind of irrelevant, which is the bigger elephant in the room that's not part of this panel. So being able to develop an application in minutes and write your schema directly into the database and have some automation in that process and be able to dynamically change that and not have it break all of your guys that are doing continuous integration, right? That stuff is all moving into all the other technology vendors because the NoSQL guys woke us up to that, woke these vendors up to that need and the relevance of that stuff. So you're going to see a lot of the things which really distinguish NoSQL technology, in my opinion, start to fade into the background because all the other incumbent vendors are going to take that stuff on. And there's going to be a few remaining things that continue to stand out, that distinguish that technology, that keep its relevance. And that's, I think, going to come down to the workload support that these technologies provide, the architecture that they have, the utilization that they provide in geo-distributed systems. It'll take a while for these other incumbent vendors to catch up on some of those aspects. So, those technologies will have taught the incumbents some good, important lessons, and everybody's taken note. They're making changes, and now, the real value is going to start coming out in these
I
different
think
systems.
Paul wanted to make a counterpoint.
So I'm not quite sure who's supposed to be Godzilla and who's Bambi in this conversation.
However you want to look at it.
My general sense is that JSON is the Godzilla in the room. I don't know who wants to play the role of Bambi, but I mean, JSON's just an extremely good idea. I'll tell you why I think it's a good idea. Number one, because it cleans up XML completely. XML never made any sense because nobody could ever explain why some of the data is stored as attributes and some of it is stored as actual entity values and which data types are allowed where and why. It never made any sense. It's incoherent. JSON has not got this problem. JSON originates in JavaScript, and JavaScript operates entirely off the concept of a dictionary. Okay? So you have a dictionary where you can index by a string or a number or whatever it is. That's an extremely flexible data type, and that's what JSON represents. It's a dictionary. What programming environment doesn't have some implementation of dictionary? Hence, everybody immediately can have complete support for JSON. If you have a dictionary type, then you support JSON. Done. Right? Therefore, it's just like boom. It's a big bang. It arrives everywhere simultaneously. doesn't have to go through some long, arduous sort of process, right? And therefore, it's the Godzilla in the room. When you get that good of an idea, it just takes over. And if you're not on that track, then you're going to get left behind, in my opinion.
Great.
I've been in the industry for 19 years. I heard the same discussion almost 12 years ago when XML was and everything went to XML, and we went and we created so many different technologies that we forgot what it was supposed to do. Today it's JSON. We'll love to see what happens 5 years from now or 8 years from now. So I think the important thing is, does JSON solve some of the problems? Absolutely. Did XML solve some of the problems? Absolutely. Was it the only thing that you expected it to be? No. Is JSON going to be the only thing that we expect it to be? No. IoT, thank you very much. IoT, which is a big business.
IoT's big hype right now.
It could be a big hype, but when there are billions of dollars associated with it, which has been quoted by great firms, I would love to be a part of that hype and build something and actually deliver. So, but the point is, there is no room for JSON over there. So does that make JSON absolutely irrelevant for the market? No, it makes it irrelevant for that particular application type. So I think it is important to kind of focus on more on the application and see what is relevant and what is not, and preferably, try and keep data as flexible and as relationship light within the repository, so your applications can gain, your businesses could grow, and you can, maybe there is a JSON 2 coming out, 5 years from now, which will be the next thing that we have seen since slice of bread. And if that is the case, great, the data stays and applications start building the relationship.
And then we'll all be back here doing this panel again.
Absolutely, we have to do something, right?
Great. Well, those are my questions. I hope you have some as well for our panel. But with that, I'm all done.
Thank you.
Hope this was as fun for you guys as it was for me.
Absolutely.
So if there are any questions, I don't know where our crowd mic is.
So I think we use this one, if you don't mind.
That's fine.
We got
That
shot
will
on mic.
be a little loud.
And I have a mic, so we're good.
Okay. I'll just try to. Okay.
You guys want to pass this one around?
I think of NoSQL as really the cure to the object relational mapping hangover. The fact is that working with developers, particularly in enterprises, they loved the ORM, they loved the fact that they didn't have to worry about transactions and their behaviors. It wasn't their problem. And there's a huge number of developers out there that think that way. I've done systems long ago that were write once for transacting between 401k systems and moving accounts that actually worked like a column store. I could never explain them to people to actually implement those things. Now, so the question really comes to you guys, you're talking NoSQL. We're using for a certain class of applications, as far as I'm concerned, that have simplified that world, that are simpler worlds. And we're trying to increase the scope of applications it supports, but it moves a lot of logic into the application, as far as I'm concerned. So I'd like to hear your comments on how we're helping developers, take logic out of the database and move it up into the application.
Is this working? I don't think that there's any necessary connection. The non-relational database is certainly MongoDB. It doesn't contain any architectural obstacle to having complex transactions. None at all. It's merely a question of the sequence of development. I mean, when we started, we concluded that there was already a big enough broad market that could be serviced by having single document transactions. So let's do that first. You always have to decide what order you're going to do things in so that you can survive to do the next thing. Right? If you try to do everything, you end up with nothing. So our order of business was to get one instance running with document level transaction, and then go to replication, then add horizontal scaling, then produce stronger query syntax, and then proceed to have embedded or modular storage layers. I mean, we're sort of chipping away one step at a time. And in my opinion, it's exactly the right thing to do. You say what you like, MongoDB, in my opinion, is a case study in how to correctly stage a startup into a market with very, very powerful incumbents, right? You've got to get a big footprint fast, or you're going to vanish. And the way you do that is to build one good thing that everybody likes because it's useful. So, to answer your question, there is no real obstacle. It's just a question of being patient.
So,
If you don't mind, I'd like to just pick up on that though. I think that your question was how are we enabling developers, to is in moving all this application launches up into their tier. Yeah, I'm not so sure I could say that's enabling developers, right? I mean, you're shifting a burden, and that goes back to the topic of this panel, schemaless revolution. Yeah, schemaless. There's no such thing as a schemaless revolution. Somebody has to take ownership of that. And so when we're enabling people with these technologies, we're doing people a disservice when we're not honest with them about the perils, right? And about the fact that, somebody does have to take ownership of that, and somebody does have to worry about governance, and when it shifts into, a non-centralized location, for example, then all of a sudden it gets much more difficult to manage. Governance becomes a real problem. You may not even be able to introduce governance depending on how it's done. And so I think that's one of the things that we as a group, speaking as Oracle NoSQL, it's our job to educate people that when we're giving you this very powerful tool, we need to teach you how to use it responsibly, because we're not just enabling you, we're giving you something you can do damage with if you're not careful.
But to that, I think we are moving to a phase where we will have less data governance than we did in the past, right? As the data volumes grow, you sometimes can't do what you did before, right? So you think of, at least how I managed my emails, right? 15 years ago or 10 years ago, I'd have a lot of folders, and every email came in, I'd drag them into my work folder, my personal folder, the folder for each of my kids, that kind of thing. Well, today I have probably like 80,000 emails in my inbox, and I can still find what I need, right? I just got better tools or different tools that enable me to cope with more data. And so I'm not organizing as much up front, but I still have technology that lets me do what I need to do. I think you saw that with Yahoo in the early days of the internet. Everything was, there's a directory of websites, the auto directory, and you go there and you see new cars, old cars, etc. Right? Well, that didn't work anymore when there were a billion websites, so we had to have other technologies to find what we need.
So I want to actually, I think we beat this one to death, right? There's no free lunch when it comes to these new technologies. Maybe we can move on to the next question.
yeah, I would like to add a little bit to the Oracle story from the SQL side. So I work in the JSON team on the relational engine. And one thing or one message we try to spread is that we say in the relational design it was schema first, data later. It means you have to do like create table before you did an insert. With JSON, what we allow now that you can insert your data and then you create a schema or different schema afterwards using like projection operators, and then you can materialize those in memory or in relational form. And what we also do is to make the work for developers easy is kind of provide this schemaless APIs which allow you to insert and to query your data without having to learn SQL. I think this is why.
So I have to kind of jump in. Is there a question?
No, this
Or is
was
it just an ad? Okay.
This was the
All right.
discussion.
All right,
Just
let's-
wanted to spread out this message. It's basically data first, schema later.
I appreciate
And
that.
we can do that in
and
the
we all do. I think we all know the Oracle URL, so we can certainly go find the information. But thank you. Is there a question?
Yeah, I've got a question. I was just wondering what the panel thought about multimodal databases like OraDB, which can operate both SQL, graph-based queries, and MySQL queries as well.
Yeah, so if your multimodal databases are those that have maybe a document store, a graph store, a key value, all in a single platform. So I'll pass this around.
I think that's a good idea, and we aim to do precisely that. Actually, the MongoDB model allows that because one component of a partition database is represented by a replica set, and the only constraint that has to be satisfied by the elements of a replica set is that they're replicating the data. There's nothing in the architecture that requires that they run the same storage engine. So you could, in principle, have 5 replicas of your database, each of them running a different storage engine. And when a query arrives, the optimizer can write a hint and direct it to the replica that contains the storage engine optimized for that query. So if you needed to do a graph type query, if there were a graph storage engine on this replica and there were a B-tree storage engine on a different replica, it would basically direct it to one or the other. So, and it would be completely transparent, right, from the application point of view. It would just look like everything that you can think of is somehow magically optimized. But it's a good idea because I think it's futile to try to find one storage engine optimized for every type of query. So you really do want a sort of multimodal storage layer.
But you
Robert,
don't
the,
have the referential integrity and probability to enforce that a particular value is linked directly or corresponds.
But we don't have reference. I mean, you store documents.
Precisely, and that's a fundamental limitation, but that's what we do.
It's a fundamental limitation to what?
Well,
Storing a
to do
graph.
efficient graph type queries.
No, not at all, because you can store a graph in a document. Why not?
Store it, but in terms of querying it. And
But you have to build the correct index.
So, Robert, actually, the NoSQL database does support key value, table style, and I believe
Yes.
documents as well. So, I mean, this is,
Yeah.
you're kind of the poster child right now for multi-model.
Well, so yes, but you know, I'll split my answer here. So we do that. Oracle Spatial and Graph works on top of the Oracle NoSQL database. We store JSON. We store things in a table, meta model if you want, with indexes and columns and constraints, or just pure key value binary, right? So we do the whole spectrum. I actually don't think that that's necessarily a good idea because I you know, I'll agree with Paul. Here's what I'll split my answer that I think certain storage technologies are inherently better at certain kinds of storage and access patterns than others. And if we try to say that we're going to create one that works good for everything, you know, we're trying to say that, you know, we can create a better hammer than the hammers that existed before. And I just, you know, I mean, maybe that day will come, you know, I'm sure there's a day when compute, memory, and all that stuff would just, you know, it's an infinite scale in all directions, and so nothing matters except your algorithm. But, you know, that's a long ways off.
Well, but you mentioned in-memory, so maybe we can talk about that, the in-memory aspect here. You can, who cares what format it's in? You can just represent whatever you want in memory, because the speed's there.
Were you agreeing with me or disagreeing with me? Sounds like you're agreeing with me.
I agreed with you on the sense that
Only on this one topic.
right on that it's not that it's not necessarily a good idea to try to create a general purpose database that does all those things. But I know you said that you guys were, but
No, that
I'm gonna-
what I said is that we could support a heterogeneous storage system.
okay.
I think you two guys should sit next to each other. So, yes, I think the, you know, I kind of partly agree with Robert on this, that creating something which is homogeneous and trying to push everything in the same repository is not a good idea. Just because the amount of data manipulation that the application developer has to do to make sense out of it as your applications change is a relatively complicated problem. And I think as all of us, you know, pretty much all of us are infrastructure providers out here, our job is to provide infrastructure which makes life easier for developers to build their applications as quickly and as fast as possible, and then let those applications dictate what kind of a model the platform should be on. So I believe that the growth of in-memory, which is a great growth for all of us, you know, all of us have some representation of in-memory in our products, essentially allows those types of applications to actually exist in today's ecosystem. You know, we have applications which are expecting personalization in few milliseconds, and you know, we all claim that we have it, and you know, some of them actually do have it. But the point is, when those types of applications come into picture, some other aspects of data, whichever manner you replicate them, from one model to another, or from no model to a model, should not be sort of, you know, coalesced into one infrastructure. Is my view.
Great.
I'll just say one last thing. So I think like one of the elephants in the room here is that actually a lot of the NoSQL revolution or NoSchema revolution has been like a great disappointment to people, right? And it's partly because, you know, people try out these databases, it's not entirely clear what you should be using them for, and the promise from the vendors is that they can be used for everything, right? For all kinds of analyses, and they're basically databases in the way that Oracle called themselves a database. And then they try to run complex transactions through them, or they try to scale them in a certain way, and it doesn't work, right? So, you know, I'm personally a believer that we're a little bit too early in this technology cycle to really be promising multimodal, you know, I can do graph analysis and I can do complex transactions and I can do this other thing and it will all work. I think that's one of the things that's led to some of the disappointment in the technologies, and I think it's the hype cycle and we're on the downwards now. And so, you know, I think one thing that's important, and I think the thing that developers really appreciate is vendors that are really honest about what they're good at and what they're not good at. So someone comes to Elasticsearch and says, hey, I want to do some complex transactions. We say, great, go use one of these other solutions. We're not optimized for that. And so I think in this noisy, competitive world, we're all trying to be what everybody else is, and then you basically make a claim that you do everything. And then you lose a lot of credibility along the way. So I think just something, you know, some food for thought.
Yes, so the question was about in-memory.
Eventually, that do you need multi-model if you have in memory, because you can create new representations on the fly?
I see. Okay, no, I don't know that that's the case, but I do think that having an in-memory model enables a range of very interesting applications, and that if you're doing business, that you don't want to leave that sector of the kind of IT economy unattended. There are huge applications that require extremely fast response time, and they will trade off replication for durability. Right? They're perfectly happy to have 2 copies in RAM on the assumption that the probability that both servers fail is low enough that they don't ever need to actually write to disk unless they're doing an organized shutdown or hibernate or something like that. But the kind of performance you expect is of a different order of magnitude than anything I've heard so far on the panel. I mean, I would expect an in-memory system to be limited only by the capacity of your network. I mean, the raw compute power should be on the order of microseconds, forget milliseconds. You're talking RAM, right? I mean, designed correctly, you're talking L3 cache. Right? So that's what you should be looking for. Now people need that, right? Because they're dealing with huge high-velocity trading systems, catalog systems, sensor streams, and they simply cannot tolerate any latency. Latency means money lost.
So let's open up for any more questions from the audience.
So one question, like with the all the NoSQL databases that are out, the ones that are going to come out, what do you see, because you're the industry experts, so what do you see is the future for the visualization technologies on top of these NoSQL databases or data sources? Specifically because most of the people have been, you know, accustomed to use SQL as a query language in most of the reporting solutions, like those. They prefer like accessing the data through JDBC, ODBC, whatever standard, you know, interfaces. So what do you see is the future for these NoSQL databases to support most of the operations that are required by these visualization technologies?
I think that will happen. I mean, the problem is that MongoDB in particular, and I think most of the non-relational databases really can't make sense out of the entire SQL standard, right? I mean, it contains functions which simply aren't represented internally by those databases. Nested queries, complex joins, and things of that kind. The real question is, do you need those to really have an effective interface to the visualization tools? And the answer to that is, I think no, and that, you know, it's pretty much inevitable that the non-relational vendors will end up supporting a sufficient subset to make that integration possible. So, because it's the right thing to do. I mean, lots of people are already using those products as part of the ecosystem. You want to be a good citizen. You want to basically reduce the amount of friction required to adopt. So why wouldn't you do that? It's really just it's kind of a question of who's going to do it. Should it be the visualization vendors who build the adapter, or should it be the database that provides the adapter? It's kind of a little bit of a negotiation.
But is a space that is left open, and I think
Well-
most of the people are just, visualization technologists, they are building small adapters, small connectors to do some of those magics, but it's not full-fledged. Otherwise, the database vendors are just focusing on like, the way that you guys are talking about, like my query performs better than your query and all that.
So that's an opportunity. Every time there's a
Well,
gap, it's like,
But I
It's,
think that's the reason we started the Apache Drill project, was exactly to provide SQL on these technologies, right? Whether it's Hadoop or MongoDB or Elasticsearch, right? So it's all about providing a SQL interface. So and there is an ODBC and a JDBC driver, so you can connect Tableau or MicroStrategy or QuickView and do analysis on all those types of data sources and bridge that connect. Because like I said earlier, a lot of data is landing in systems today that don't do SQL. Yet there are millions of people out there that know SQL, and there are lots of very, very good tools that people love, like Tableau, that know how to take SQL and do great, self-service BI visualizations.
What's interesting is the fact of the matter is most of these NoSQL solutions are used embedded in applications, right? People are typically doing ad hoc analysis using visualization tools. And you ask yourself, like, why is there no Tableau for a NoSQL solution? Why is there no Tableau standard product or ClickTech type product that runs on top of MongoDB, right? And the fact is that you can slap it on there and you can build a SQL interface and a JDBC, ODBC connector, and it's crap, right? You don't have the full functionality, it's slow, it just doesn't meld well, right? There's a whole set of problems that people end up running into. And so I think it is a gap. I think there's an opportunity. At Elasticsearch we have our own visualization product, Kibana, right, which was specifically designed for doing Elasticsearch queries and doing aggregations. I'm not saying that's the best thing in the world, in the sense that it's designed only for Elasticsearch, but it works really well, and it's one of the differentiators for our product. That said, it's not SQL, right? So it's not as commonly used as something like Tableau. So there's a trade-off there, but I do think it's an opportunity for a new vendor to come along and build a visualization system that works on top of a lot of these products. But today, it's up to the vendor to build one. At least for Elasticsearch, that's what we did.
So I think we've got time for one more question. We can take two more. Two more? All right, great.
So my question is, I'm not a database guy, so I can ask a stupid question. Last year I was going to NoSchema conferences, and there was a great deal of movement toward machine learning, and there was a great deal of discussion of MapReduce and Hadoop or even Spark. My question is that a trajectory still there for MapReduce? And when you look at the operations of MapReduce, for instance, you have sorting, shuffle, and aggregation, and reduce functions, which are mostly cumulative and associative.